we finished the demo sometime back, maybe around 1 or 2 weeks back. But since there are quite a few people, let us just go through the introduction of this thing, and then we'll start with the class. We are supposed to start the class today, which is Linux basics. But let us quickly go through the introduction of DevOps. Okay. Okay, so basically, when we talk about DevOps, we basically we have to understand what is the software development methodology. Right. Okay, so in general, in any organization, how the software is developed, right? So let us say there is a requirement and that has to be converted to a project and software, right? So for that, there are stages, right? So this you would have studied in your graduation as part of, computers subjects, right? So basically it's like we gather the requirements from the customer. So that's requirement analysis. Right, so basically this is done by the line of business people or the managers. Then we do the design. So in the design also we have something like high level design, low level design. So that is generally done by the architects, right? So this requirement analysis is generally done by the line of business people or managers, right? Then the design. Then comes the part is coding, which is like generally done by the developers. So when I say design, it will be something like high level design, low level design, wherein we basically decide which is the operating system we want to support, which is the programming language you want to support, which is the scripting language you want to use. And when it comes to low level design, it's like we'll drill down to the basics, like what are the components we should have, how the project should look like, that kind of things, right? Then when in the coding, developers as per the design code based on the programming language, then test. So test in the sense there are different phases like unit test, functionality test, and then system test, then acceptance test, user acceptance test, load test. So once everything is done, then we push the code to the production, right? So this is the regularly a software development methodology, right? So what used to happen, let us say I have an idea, which is something like a Facebook or any e-commerce site like Amazon or whatever, right? So this is an idea. This has to be converted to a project. So any project which has to be converted to a software has to go through all these phases, right? So let us take an example. So this is the conventional approach. So this used to take a couple of months, right? Earlier, this used to take a couple of months. But what is happening? What is the problem with this approach now? Let us take example of waterfall model. So first requirements has to be gathered, then design has to be completed, then coding, then test, then we move it to the production, right? So let us say this is taking 6 months of time. Right. So currently what is happening is customers are expecting faster deployments in the sense you open any website, right? So Amazon, you open Amazon and you see there is an offer. Now, after half an hour, you see something else on the website. After another half an hour, you see something else, 20% off, 30% off. It's keep on changing, right? So what is happening internally? So the deployment is happening very fast. So some of the companies are expecting deployments to be done in 1 month. Some companies are expecting to be done in 1 week, or in some companies 1 day, or some companies within 30 minutes. Also, they are expecting the deployment. So what is deployment? Something like, let us say there is an application. It can be anything. It's a Citibank application or HDFC or Amazon or anything. It is actually running on a server, which is inside a data center, right? So there is someone who is maintaining it. There is a team, there is a production team, there is a development team, there is a test team, there is a design team, right? So when something has to be done, right? So let us say there is a new feature has to be added to the website, right? So there is a design team who does the design, there is a development team who does the coding, and there is a test team who tests, and there is a production team who pushes it to the server, right? So again, all these phases are followed, but that is like not in 6 months of time, but within few minutes the deployment is happening. So how is this happening? This is happening because of end-to-end automation, right? So it is something like, you can't hear? Just a minute. Can everybody please go on mute? Okay, so basically it's like the deployments have to be done very faster in a very quicker fashion, so that, and it has to be done accurately. So that's the reason why we have this end-to-end automation. So everything has to be automated. For example, something like, let us take an example of so there is a development team, there is a test team, there is a production team, right? Can someone please go on mute? Thank you. So basically, let us say there is a developer. So basically, developer does coding, right? So coding in the sense, when multiple people are working on a single project, they store their software on a repository, right? So that can be SVN or Git or ClearCase or any other versioning system, right? So basically, it's like we don't store our software on the laptop, we store it on a centralized server, so that even if the laptop crashes, you have the code on the centralized server, right? So we basically develop the software and then we push it to the centralized server. So multiple people will be using that centralized server for storing the source code, right? So let us take an example. So Monday morning, I'm a developer, I have fixed something in the Monday morning, right? And then, so here, this is a conventional approach wherein previously there was no automation. It's like everything is manual. So there is a build team that has to convert this source code to binary. So what do you mean by binary or artifacts? So there's something like you have Java source code, you have written something like hello world program, then that has to be converted to a binary, in the sense a var file or EAR file or jar file. So that is what we ship it to the customer. We directly do not ship the source code. Source code is nothing but the code which you write, and then we compile it, we build it to create the binaries, right? So that binary we generally ship it to the customer, right? So who does that? That generally done by the build team. So there is a development team who does the coding. There is a build team who actually does the creating the binaries from the source code. So basically it is nothing but compiling, right? So once that is done, then we push the code to the test team. Let us say testing team does the test, and they take the binary and they test it, they run their test cases, and if everything is fine, they declare it as a passed. Then what is the next step? Then we push it to the production team and asking that testing is completed, please push it to the production. Once we push it to production, we have the application or the website which is functional. So these are the phases which it goes through, right? So development, testing, production. So there are different phases. In development also we have unit testing. In testing also we have functional testing, system testing, etc. So everything is completed. Once we make sure that everything is fine, then we move it to the production, right? So let us say in the conventional life cycle in waterfall model, what is happening? So there is a build team, but there is no proper automation tool they are using. So they are doing manually. Let us say it is taking 1 day for them to create the build, and there is a test team and they are taking 3 days of time to test, right? And let us take out this part for now. So I'm a developer, I just pushed something, a small fix in the Monday morning, and build team has took 1 day to convert it to binary. Then test team has tested 3 days, okay, to test it, right? So entirely it is taking 4 or 5 days time just to check whether my fix is working fine or not, right? So just to understand a small fix which I have given, a bug fix or a feature or anything, to make it working or just to get the feedback whether it is working fine or not, it is taking 4 to 5 days of time. So there is a lag in the process, right? What is it? Build team is doing it manually and test team is again doing it manually. So can we enhance this by talking to different people and asking them to automate something like, let us say, there is a build team, then we can ask them to use the tools like Ant and Maven and ask them to create the build within, let us say, 1 hour. And then there is a test team which actually testing for 3 days. So maybe we can ask them to use some tools, automate the test cases, reduce the test cases and increase the coverage, and maybe they have to finish in 4 hours, right? And then we develop a framework which is like end-to-end automation. So what is the problem with this approach is something like there is a lag in the process, and let us say build team has completed building at night 1 o'clock and they send a mail to test team saying that build is ready, please test it, right? So again, next day morning, test team has to come and start testing, right? In the same way, let us say test team has completed around 10 o'clock in the night and they have to send a mail to production, please push it to the production. So this is like everybody is waiting for someone else. There is a manual intervention in every stage, right? So in the same way, developer will fix it and he'll send a mail to build team saying that my fix is ready, please build it. So that is again, there is a manual intervention at every stage. So can we automate in such a way that when developer pushes something, immediately, let us say developer has pushed something, immediately build has to happen, immediately test has to happen, and a mail has to be circulated to everyone saying that number of test cases passed, number of test cases failed, and like number of tests, total number of tests passed and failed. This kind of information we send out in HTML format. So what is the advantage with this process? There is no manual intervention. Nobody is waiting for anybody. So let us say I'm a developer. I push something in Monday morning. So I'll get the result by Monday evening, right? So we don't have to wait for the complete week just to find out whether my fix is working or fine or not, right? So what do we do to achieve this? So basically we need to use some tools, right? So these tools will basically build, will act as a repository, will test it, and then will send out the mail to all the people involved saying that these are the number of tests, this is the fix which is applied, this is the build which we worked on, and these are the results, right? So manual intervention is avoided. So to achieve this, we need to have the end-to-end automation. So basically build team has to use, we have to convince build team to use the automation tools. We have to convince test team to automate the things. Without test team automating their stuff, we cannot really go for this, right? So this kind of end-to-end automation is called continuous integration, right? So what are the tools we use for this? So there is a tool called Jenkins, which is continuous integration server, using which we can achieve this end-to-end automation. So this is a kind of framework wherein we need to add other tools like version control tool or build tool or some other tools which we'll learn in the course of time, using which we can achieve continuous integration. Any questions so far?
No.
Okay, so this is one perspective of looking at the DevOps. The other thing is, so dev and ops, development and operations. So this is a set of principles or methodology wherein development and operations team collaborate to form a new model called DevOps, right? So what does development do? They basically focus on coding, right? Developers means generally they do coding. So when I say development team, it is like developers testers, and let us say build team, or you can also call something like analyst, architects. All these things are part of, let us say, development sphere, right? And then when I say production, release engineer or Linux admin, database admin. So all these people come under operations team, right? So when these two different spheres collaborate together, that is called DevOps, right? So the motto of this team is to develop code. So they do not bother about the stability, right? They do not bother about the high availability. So whereas this team, they bother about, they don't bother about the coding. What they bother about, their system has to be always up, right? So you open a Citibank application and it has to be always up, right? So it shouldn't be down. So if any application is down, it's like direct business loss to the client, right? So who will be questioned? The person who will be questioned is the system admin, or you can call system admin, right? So this system admin, generally they are scared of pushing the changes to the servers, because they always bother about the high availability. High availability in the sense, always the server, the machine has to be available. Always the application which is running on a server has to be available, right? So you open any site, that has to be available to the customer. If by any chance, if the server or the application goes down, it is a directly business loss to the customer, right? So in this case, let us say I'm a system admin and there are 100 machines in my lab, right? So, and there is a, let us say, there is a software X is running with the version 1.0. Now there is a new version developed in the market, which is 2.0. So I need to upgrade all my machines to 2.0, right? So how do I upgrade manually? So I need to log into each machine and upgrade. There will be some procedure to upgrade, and then I need to come back like that. One by one I need to go through. So let us say I have 100 machines, so I need to, let us say if the one machine is taking 10 minutes of time, for 100 minutes it will take 100 machines, it will take 1000 minutes of time, right? So fine, so let us say I do it manually. I log into each machine, I upgrade it, and I come back and log into the second machine. So this will take 1000 minutes of time. So let us say I have 1 lakh servers. So how do we update this software, right? So the famous companies like Google or Facebook or Twitter, all these companies have servers in around greater than 10 lakhs. Right, so for simply updating a software or applying a patch or creating a user for anything, so we need to log into each machine and do it. So that is like a tedious job, right? So how do we automate this, or how do we enhance this? So further we have tools. So what do we do is, basically we have tools, like one of them we configure as server. Let us say I have 100 machines. So one of them is a server, and the remaining 99 servers we configure as clients. Okay, this one server is called, let us say, server or master or whatever, right? This client is called client or agent. Then what do we do is, so basically we need to update the software. So for that, I'll not do manually, I'll write a script. So this will not be something like a Java programming language or C programming language. It will be simple script that is like a general English. So basically we write something like install this, start the service, some kind of syntax will be there, but it's more or less like a English, right? So that we write a script, and that when we execute it, it will automatically execute on all the machines. Here we are not doing manually, but here we are doing automatically using a script. For example, let us take a scenario wherein I'm a Linux admin, right? And there is a developer who comes to me and asks me to configure MySQL on one of his machine. So I work for 30 minutes and I configure MySQL. So tomorrow again one more developer comes to me and asks to configure MySQL. Again I'll take 30 minutes and configure MySQL, right? So basically database. So like this, whenever someone comes and I'm configuring it manually, and getting it ready and giving it to the developer. Okay, so in DevOps model, that will not happen. So in DevOps, in production, operations guy also thinks like a developer. How is that possible? Let us say someone comes to me and asks to configure MySQL. What I'll do is I'll not do manually. I'll write a script. I'll write a file. That file does MySQL installation configuration on the machine, right? So this is a one-time job. For the first time, let us say I write the script, and tomorrow morning again someone else comes and asks me. Now again I'll not do MySQL configuration manually. I'll just call the script. So this script does the job. So here system admin is coding actually, and he's maintaining his code. What do you mean by maintaining? Something like he's storing his code on a centralized server, and there is versions associated with each file, 1.0, 2.0, right? So this is nothing but operations guy thinking like a developer is DevOps, right? So basically here generally system admin will not code. He'll simply does the installation configuration. But in DevOps model, system admin guy is also thinks like a developer. He writes the code, he maintains the code. So that is DevOps model, right? So here we are maintaining our code as a infrastructure as a code. For anything and everything, we write a code and we maintain it in a repository. And if there is any need, there is any requirement to configure something, we just execute that code. That code will go and perform the something like installation or configuration, adding the user, applying a patch, upgrading, or installing something. So for anything and everything, we write the code and that code does the job. So this is called DevOps. Any questions so far?
Hi, Santosh. Sorry.
Yes.
Hello. Uh,
Yeah, who is
actually,
this?
I'm totally. Can you hear me?
Yes, tell me.
I'm totally new to this subject wise. Do we need to have like specialized like training prior to have this one, or I can manage or cope up with what with the training session that
So
I'm going to take in future?
I'll come to that. So basically what we should have is SDLC knowledge, software development lifecycle knowledge, and we should have knowledge on Linux operating system, but this anyway will start from scratch.
Okay.
So this knowledge is enough. Okay.
So basically, I can start up because I do have a computer science engineering, but
Yes, yeah,
education is different when compared to the practical thing. That's why
yeah,
I'm a bit concerned.
yeah, that would be fine. Yes, this anyway will start from scratch. So all the tools will start from scratch, so that would be fine, I guess.
Okay.
Hi Santosh.
Yep.
Yes.
Hello. Santosh Vishal here. I have one question. You are telling the client and master. Is it chef and puppet in the picture for this as well?
Exactly. So this is like tools like Chef, Puppet, Ansible. All does the same thing. So this one of them
Okay.
is
So
master, the other is the
any,
clients.
okay. So we require any scripting language also, like Python, Perl, all shell scripting, right? For this.
So we will cover shell and Python. But for using this, we may not need all these things because everything is ready-made. We can use them by downloading some of the modules and directly we can use by writing some sample scripts. There will be some modules already available that we can download and use, but still if you want to customize, we can do that using languages like Ruby and Python.
Okay. You
Okay.
mean to say the chef puppet is a means is a connected with different name in the AWS, right? Means it's the same tool which is working with the same features like the shape and puppet, right?
So Chef and Puppet are called configuration management or continuous deployment tools. Basically, if you have multiple servers and you want to perform something, we cannot do manually on all the servers. So using Chef and Puppet or Ansible, any one of them, we can automate the everything so that we do it automatically.
Okay. Okay, that's it. All right.
Yeah. Can everybody please go on mute?
Hello.
Hello. Yes.
This is Krishna. I have two questions.
Mhm.
Yeah, first question. Before entering to this course, what technologies we know?
I think I just answered. So this kind of little bit of computers knowledge and software development life cycle. So that would be
Okay.
enough.
Okay. Second one is, hello.
Yes. Go ahead.
Yeah. Second one is in the market available two course. First one AWS and second one DevOps. Which one we will go first?
So anything based on your interest, you can go. So here we also cover AWS, but that
Okay.
will not be complete full-fledged. It will
Okay.
be how much ever required for the course.
Okay.
Something like EC2, IAM, S3, VPC, DNS, RDS. These are the things which are going to cover the basics of AWS.
Okay.
Okay.
Okay. Thank you.
Yeah. So far we have discussed the continuous integration and configuration management, right? And so there is also something called monitoring, and there is also something called creating development environment. What is monitoring? Let us say there are hundreds of servers and we need to monitor them. So because of any reason, if the CPU increases on the machine will go down. Again, the application will go down. So continuously we need to monitor. How do we monitor? So we have to log into each machine and see the CPU usage, the memory usage, the file system usage, right? Basically, if the RAM goes full, your application will go down, right? So how do we monitor that manually? Manually monitoring multiple machines is difficult, so right? So we have tools like Nagios, which does the monitoring. So Nagios is kind of a graphical user interface. We can add all our servers to it, and it will show the CPU usage or whatever the requirement on the graphical console. So if anything is going wrong, it will change the color to red. So as an administrator, I need to log into the machine and understand what is the problem, right? So that is what is monitoring. So for that, we have tools like Nagios. So for continuous integration with tools like Jenkins, configuration management, we have Chef, Puppet, Ansible, and so for this we have a tool called Vagrant. So this is like for creating lab, right? Let us say you want to practice some tool. So how do we practice? So either we should go to lab in institute or
Hello.
yes.
Santosh, I want to ask you one question. Can we use Jenkins for continuous deployment as well?
Yes, so when I say continuous integration, it is continuous deployment, continuous delivery, all this come under the same. I'll tell you what's the difference between all these things, but for now, just understand continuous integration is testing the fixes continuously.
Okay, yeah,
Okay?
got it. Yeah, okay.
So to practice, let us say you want to practice some Linux commands. So if you just have a laptop and internet connection, that is enough. If you have this Vagrant tool, with just 3 commands, we can get a VM up and running. So that is Vagrant tool, right? So you just execute 3 steps using which we can get one environment. So what happens is internally we download a Linux image to the laptop. On top of that, it will create a VM. Then we can log into the VM and use it. Something like this, right? So this is a Linux machine. This is CentOS 7. So how is this happening? Using a tool called Vagrant. So there are only simple 3 steps. We just have to download something on the Windows laptop or Linux laptop or Mac. Then just install this tool that will create an environment for us. This is just for your practice. Any questions? Okay, then we have a concept called virtualization. As part of that, we cover
Yeah,
Dockers, containers.
yeah, Santosh, Ramesh here.
Yes, Ramesh.
Yeah. See, if I have like AWS knowledge and like if I can create EC2 instances, so there is no need of going with Vagrant, right?
Right, exactly. Yes, there is no need.
Will, or else will it gives additional knowledge? You know?
Yeah, this is good to have. Basically, something like when we don't have internet connection, also you can work with your laptop, right? You have laptop means you have lab available.
Okay, 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 sir. Thank you.
But in that case, Santosh, we can use a virtual box as well,
Yeah, this is what is
rather than
VirtualBox.
using.
Vagrant not alone. This internal uses again vehicle virtual
Okay,
box.
okay,
Okay,
got it.
right? And then we have version control tools like Git, GitHub, and then what else we have? So it starts with Linux. So in a nutshell, this is the course. And here comes some these tools for converting our source code to binary. And then something like we store our source code on version control system, right? So for maintaining the versions and checking who's modifying what, right? So that is called version control system like Git or GitHub. We also have to store our binaries on some centralized server, right? So for that, we use tools called Nexus, right? For storing the source code, for storing the code, basically, let's say you have a Java program, we use Git or GitHub. And when we convert that binary also we have to store, right? Let us say in the organization, there is a problem now, there is a defect, and we need to go back to the previous version. We need to have the binary from the previous build that we store it on a tools like Nexus or Artifactory. Okay, and then one end-to-end integration, something like we design a project. That project, if some developer modifies something, everything has to happen automatically, right? So let us say I'm a developer, I modified something on Git. It has to build it, then it has to store it on the Artifactory, then it has to start the test, then it has to deploy. So all these things is called workflow. Workflow is nothing but a complete end-to-end workflow. So I think this will be the first question in any interview. Something like, what is the workflow? What are the tools you have used? How did your project work? So basically, it's like what is the version control tool you are using? What is the build tool you are using? What is the continuous integration tool you're using? What is the configuration management tools you are using to deploy that to different servers, right? So it's like, I mean, so when you complete this thing, the codes, and you need to modify your projects in such a way that you have to tell like, I worked on this, and this is the flow, and this is how it works, right? So there is a development team, there is a test team, there is a build team, there is a production team, and so DevOps is like collaborating between all these teams. And when developer modifies something, all the end-to-end integration should happen using the tools like Jenkins. So Jenkins is the kind of framework wherein we chip in all these tools like Git and Nexus to it. So this will detect if there is any change in the repository, and it will create a build. Then that build will be pushed to Artifactory or Nexus. Then using tools like Chef, Puppet, or Ansible, we deploy that to the test machines. And if testing is successful, we move that code to the production. Now, once it is moved to the production, so it is accessible to anybody, in the sense that feature will be available in the market. Is this clear, or did I miss anything in the course?
Hi, Santosh Mazhar here.
Yes.
These are like a lot of things to like concentrate on. Are we going to cover up in like during the time like 45 days, and how much do we cover and how much can I learn from the course?
So it is like from the scratch installation. Let us say you're talking about something, Chef, installing Chef on one of the machines or multiple machines, 3 machines, then configuration. Just for example, then we write some of the scripts. That scripts does the automation, right? So this is like, let us say, this is one of the tool called Puppet. This we can install on one of the machines and we can write the scripts and see what is happening. So this is like hands-on. And then we download some of the modules from the net and how to use them inside the machines to automate something. So till that level, it is like from the start installation to downloading modules from the net and using them. Okay.
Okay. Now the reason was I don't have any knowledge on this. That's why I'm a bit concerned how I'm going to
Right.
cope up with the subject. Yeah.
Yeah, you can attend few classes and decide yourself like you're able to follow or not.
Okay, yeah, no worries.
Okay.
Thanks, Santosh.
Yeah. So
Hi, Santosh.
yes.
Hello. Santosh, now I'm working as a Unix and Linux administrator since 4.5 years. So
Mhm.
I have a little concern about that. Nowadays, all companies saying we are doing the automation. So is that the part like this is a means I would like to say this is the part of the automation.
Yes, this is the
Is it
part. This is what is DevOps. This is what is end-to-end automation using the tools. So if you have the knowledge on Linux, it's like you can play with the tools. You can configure them and you can install them and you can do a lot of things.
okay? So which is better and better for the market? Means I would like to say the architect associate for AWS architect associate for course or the DevOps. Which one is better for me as of now?
Uh, I think it would be better if you have two, because you have some instances also in cloud. You need to manage them, right? You have 100 instances in cloud. How do you manage them? So you have to again use the tools like configuration management tools, and you have to have end-to-end integration. So again, all these tools will come into picture, right?
Okay. Okay, all right. Thanks.
Okay. So today actually it's not demo. It's actually I was supposed to start the class, but since there are a few people who did not attend, I just gone through this. So we'll basically touch upon. We still have 10 minutes, so we'll just go through some of the fundamentals. Okay. So what is operating system? Anybody can define what is OS?
Interface between the user and the system.
Excellent, right? Yeah. Any other these things?
The collection of running programs.
Right. So it's basically like, let us say I want to store data in my laptop. Let us say I want to open a document and I want to write something and just save it using Control S, right? So basically we are writing some data to a Word document, right? So basically here I'm instructing my hardware to save them data. But as you know, hardware only understands zeros and ones. Right? So this is nothing but binary language. So as a user, I only understand English. So how do I talk to my hardware which only understands binary language, right? So let us say, just take a simple example. let us say I know English and I know only English, let us say, and I want to talk to a guy who knows Hindi. So how do I talk? Even if I start in English, he cannot understand. Even he responds back in Hindi, I cannot understand. So there should be some kind of translator who understands both English and Hindi, right? So when I talk to this guy in English, he translates to this guy in Hindi, and when he comes back, when he responds back, again he'll translate to me in English. So basically, that is what a job of translator, right? So if I replace this analogy with software, so there is a user and there is an operating system and there is a hardware. So basically, operating system is a set of software which is like an interface between the user and the hardware. So if I want to communicate to hardware, I need to communicate through a layer of operating system or software that is called operating system. Basically, a set of softwares which acts as the interface between the user and the hardware. That is nothing but operating system, right? So we have used primarily Windows, Linux, Mac, etc., etc. There are a lot of operating systems, right? So basically, when you talk about servers, it's mostly Linux operating system, right? So you have some application running on one of the server. So most probably that server has Linux as the operating system, and on top of that, application is running, right? So most of the time when we talk about the DevOps, or most of the time when we talk about AWS, it's mostly Linux is the operating system. To understand this course, to learn this course more effectively, what we need is the Linux knowledge, right? So let's start with the Linux. So before that, there was no Linux. There was Unix operating system developed in 1960s by a guy called Dennis Ritchie. You remember who is this guy?
Yeah.
Anybody? Anybody?
Yeah, he founded C language also.
Exactly. So this is
Yes.
the guy who developed C language. He also developed an operating system called Unix in the 1960s, and most of the time, most of the Unix, this thing is developed in C language, right? So what was the problem with Unix? When you say Unix, what are the flavors of Unix? So basically Unix, IBM AIX, HP UX, Sun Solaris. These are the different flavors of Unix, right? So these are the companies who used to develop operating system, and they used to, so basically this is like platform dependent. In the sense, AX runs only on IBM machines, HPX runs only on HP blades, Sun Solaris runs only on the Sun machines, right? So if I use Sun Solaris on IBM machines, it doesn't work. So these are the hardware vendors, right? So let us say you want to start an organization, start a company. We have to buy the hardware from somewhere, right? So those hardware vendors are these companies, IBM, HP, and Sun. We need to buy hardware from them. We need to install the operating system on top of their machines. So if we use Unix, the problem is only it is very much platform dependent, and this is licensed. We cannot simply download this from the internet and install. So we have to buy the license as well, right? So AIX runs only on IBM machines and not on HPUX or Sun machines or HP machines. In the same way, Solaris runs only on Sun machines, right? This kind of dependency is there, and they are not open source. Right? So it is like, let us say, if someone wants to see the source code, what is there inside this operating system, we cannot see because the source code is not open to everybody and it is licensed. So to address all these things, so a guy called Linus Torvalds developed an operating system called Linux. Okay, he actually developed something called kernel. We'll see what is kernel later. So let us say, for now, understand that he developed an operating system which is Linux, and he then most of the companies took that kernel and they developed their own applications around that. So that is called distribution. So they took this Linux kernel and they developed their own utilities, applications, commands around that, and they call it as a distribution. So there are a lot of Linux distributions available in the market. So the primary ones are RHEL, Red Hat, Enterprise, Linux, SUSE, Linux Enterprise, Linux, and then we have Ubuntu, we have CentOS, we have Fedora, right? So these are the Linux different flavors. And when we say when you are working on Linux, the next question will be, I mean, just to find out whether you're working genuinely or you're simply saying you're working on Linux, the question will be, what is the flavor of Linux? So you tell I'm working on Red Hat or let's say or Ubuntu. Then the next question will be, what is the version? So the current versions you have to be familiar with. The current version of Red Hat is RHEL 7. Okay, and SLES is SLES 12. Ubuntu is 17.10. So these are the versions. So for every product, there will be a version associated with, right? Java 8, Java 9. In the same way, operating system also will have some version. CentOS 7, Fedora 25. Again, there will be some service packs with each. RHEL 7, SP3, SP4, SLES 12, SP1, SP2, something like that. But these are the primary versions. So what are the advantages of Linux compared to Unix? This thing is open source. Anybody can download and use it. The second thing is it's free. You're not charged for it. And then it is platform independent, sorry. Right? So this operating system you can just download from the internet and you can run it anywhere. It runs on the mobile, it runs on the laptop, it runs on the server, irrespective of the hardware. It runs on IBM machines, it runs on HP machines, it runs on Sun machines, right? So it's free. You can also see the source code. If you want to develop your own features around that, you can develop. And so basically it's platform independent. So these are the primary differences between the Unix and Linux. Okay, so that's the reason why Linux picked up, and there are a lot of open source software available in the market, which we can readily install on the Linux and use it, right? So when we say operating system, it's the interface between the user and the hardware. And there are different kinds of operating system, Unix and Linux. Unix is developed by Dennis Ritchie, Linux is developed by Linus Torvalds. And Unix is platform dependent and it's not open source. The flavors of Unix are IBM AX, HP UX, Sun Solaris. And when we say Linux, there are a lot of distributions. These are the primary ones. RHEL, developed by Red Hat, SLES, developed by Novell, Ubuntu, this is the open source community, Debian, they developed it, and CentOS is again RHEL distribution. These two are again RHEL distributions. Okay, so we can directly download this from the internet. We can install it on any of the machines, whether it is a laptop or mobile or server. Then, so basically it works on any hardware, whether it's IBM AX or HP UX or Sun Solaris. So that's the primary difference. So what is the difference between the Windows and Linux? So Windows is more suitable for the user experience, user level, in the sense for desktop versions. But when you talk about Linux, it's more suitable for the server edition. So basically you want to have very huge server setup inside a data center with a lot of applications running, a lot of scalable applications, highly available application. In that case, we choose Linux. Okay. Whereas you just want to work on something like Word documents or PPTs, where you just want to open something and open a browser and check your sites and that kind of user level experience, use Windows. Linux also has the desktop versions. In the same way, Windows also has the server edition. But what is most preferred is Windows for the user level, Linux for the server editions, right? Let us just take one example. This is called capitalization. I create a directory folder with DevOps. Then I create another directory with small DevOps. Will this work or not? This works or this doesn't work?
It should.
It works.
Doesn't work in
It should
Windows.
work.
This
In
will not
Linux,
work. This will not work in Windows because Windows is, so this is called capitalization. So basically Linux is case sensitive. It bothers about the case. So basically you can create any number of folders like this in Linux. Whereas in Windows, if you just create DevOps, that's all. You cannot create any folders with caps. This is called capitalization. So there are like a lot of differences between Windows and Linux. We'll see in the coming classes. So this is the basic class just to understand what is Windows, what is Unix, and what is Linux. Okay, we'll stop here. We'll continue tomorrow. Any other questions?
Hi Santosh, Mathari here backing.
Yeah, tell me.
Do we get a material for the subject?
Yes, we get everything. So basically whatever we teach, it will be available this way.
Okay. Yeah.
Santosh, are we going to get the recorded sessions?
Yes. We get that, yeah, we get it.
Okay, thank you.
Santosh, one more thing. Are we like what are you going to cover for AWS? Like you've already mentioned, like S3, IAM, EC2, but how much in brief are you going to cover those in brief or in depth? How is it going to be?
This will be 5 to 6 classes. It won't be too much deep like a regular AWS because that will take around 40 days, right? So it will be the basics.
Okay.
Okay.
Okay. So okay. Yeah.
Okay.
So do you offer courses for AWS as well?
Yeah, we do have, but right now I'm not taking. Someone else will be available to take that.
Okay, so after this course, can we go for AWS course as well?
Yeah, sure. But this, I think this will be sufficient with little bit of reading. But if you still need, you can go. Yeah.
Okay, yeah. Thanks.
Santosh, another question. How many days you cover Linux part?
It's around 2 weeks.
2
Linux
weeks.
plus shell scripting.
Okay. Are you going to cover
And
Python,
how much
right?
time for,
Yeah, that will be at the end. Yes.
and how much time for Linux?
This including this thing, Linux and shell scripting.
Okay.
Hi Santosh, Vishal here.
Yes.
Hello.
Yeah, tell me.
You recently said that, so I assume that it covers associate part also in the DevOps.
Not completely, but most of the things it covers. Something like
So in
this
future,
thing.
if I want to work on just means in future I need to work on only the associate architect part. So is it possible it will be sufficient knowledge for this?
I think it will be sufficient, but not completely. Maybe you have to go through a little bit of documentation to clear that.
Okay, and the class will be regularly running in the same time or some, because I am working in the shift, so might be it will be sometime I'm in the EMEA shift, so I'm not able to attend this class. So
I think
what?
you'll be given some of the videos. Maybe you can go through, or maybe then if you miss something and if you want to attend interactively, you can attend the next batch as well.
Okay, okay, understand. Thank you.
So Santosh, this is the timing, 6 to 7
Right.
every week or every day.
Every day, and we also take some of the weekends, not now, but after some time, maybe 2 or 3 hours in weekends,
Okay.
2 or 3 weekends. And
This is the only available time.
this is the available time because
Okay.
I'm in US now, and it's 7:30 a.m. for me now.
Oh,
Oh, okay.
So anybody from US or
one
everybody
minute.
from India?
I'm from India.
Okay, okay.
Hi Santosh, I'm from US. This is Venkat.
Which timing? PST?
I'm in Central Time. Iowa.
Okay, 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 fine. Yeah. Which place?
Iowa. I'm from Des Moines.
Okay, okay. Anything else?
Monday to Friday, right?
Right, right.
No?
As of now, yes, it's Monday to Friday. We'll stop here. Yes.
During weekends, you said like we are going to take like 2 or 3 hours. What would be that expected time?
That will inform later. Mostly it will be same time in the morning for you in the evening. Or we will decide
Okay.
based on the availability.
Okay, no worries.
Okay. Okay, then we'll meet at the same time tomorrow. Okay, we'll wind up. Thank you. Bye-bye.
Thank you. Bye bye.
Bye-bye.